is that what happens a lot of times in geometry, we reintroduce some sort of an algebraic part to it, but we put it in intertwined with geometry terms. So what we're going to be able to do is work with geometry via using algebra skills that we've already learned. It sounds like it's really weird, but once you see a couple of these problems, you'll be like, oh, that's not bad at all. Again, calculators. The calculator stuff that we're doing today, or actually basically this first chapter, it's not going to be anything too crazy. You don't have to worry about too much about having a fancier, the nicer calculator at all yet. The Chromebook one that you have for your homework will be fine. A cell phone one for homework, whatever, will be fine. You will not be able to use a phone or a Chromebook on a quiz, though, just so you guys know. Yes, sir. You'll be fine with that one. I will say one thing: as we get further along, we start taking square roots and stuff with that. It's just going to give you a decimal. So that's when you're going to want to really rely upon getting that other one because it'll simplify them for you, makes your life a lot easier. Also, if you know how to manipulate that one the right way to get fractions, fractions are always a lot cleaner as far as an answer is concerned. One of the reasons that I do a big push on fractions in this class is that next year in Algebra 2, fractions become more involved. You will find out that if you use fractions, math is easier, especially getting Algebra 2. Okay? Segment measuring. Yes, sir. It's fine. Again, if you know the right way to create the fraction bars and stuff like that on there, you'll be all right. It does not do the square root things, but I can show you a trick on how to do that with that one, because that one has a table function on it, right? Yeah, I can show you a trick how to simplify some stuff on that. It won't be a big deal. I know that the district had a big push for everybody to buy a TI-73 about 4 or 5 years ago. Everybody should buy one. It's the greatest calculator ever. No, it's junk. All you needed to buy ever really was this multi-view calculator. By the time you get to high school in Algebra 2, here's this one. It's fine. You won't be able to do roots and things. I'm just messing with you. Have you figured that out yet? Yes, by all means. Seriously. I harass. That's what I do.
So if I harass you back, what I can do?
It depends on how bad it is. All right, so segment measuring. You guys have all used a tape measure or a ruler at some point in your lives, correct?
No. Yeah.
I'm like, really? All right, you all know how to measure something, how to figure out the distance between something. Will your distances when you measure stuff ever be negative?
No.
No. Why is that?
Because you're not right.
Because you can't what? You can't measure backwards. Can you walk backwards?
Yeah.
What happens when you walk backwards?
Still walk.
You're still walking, right? You're still going some specific distance, aren't you? It's just a direction, okay? That's what happens with math. You get different directions that allow you to move forward and backward. So what we do is, when you're looking at a segment, it doesn't matter how you measure it out. Whether your segments are given to you within numerical values, or you're using like a ruler and you're starting at 0, you're measuring it outward, or you're on a number line. For example, let's say point A is at 11 and point B is at 23. How far apart are they? How did you do that so amazingly fast without the use of a calculator? I don't either. You just did. But what did you do? What did you do? You just said it. You subtract. What you did is you took the far part and you subtract the close one. Very simple. In essence, what that really is that you're finding a distance.
Yeah.
Lengths will always be positive. There's a terminology in math that allows you to create something that's always going to be positive. And it has a relation about distance from 0. Do you know what that's called? Yes, sir. That's absolute number and absolute value. Remember what those bars look like, those verticals? Basically what happens here is that you take what's called the absolute value of the difference of the endpoints. In this case, both our numbers were positive, 23 minus 11. It gives me a positive answer, so it's 12. If my numbers were both negative, well, this one would be negative 11, and let's say this is 3. How far apart are those? Well, they're 14, aren't they? They're 14. What you would do then in this case, you take 3 minus the negative 11. Okay, that's how that would work. All right. It is super fast stuff to do. All you're doing really is counting when you're talking about number stuff here. So your distance between segments is winds up being the absolute value of the numericals. Okay. Again, this is nothing that nothing you couldn't figure out on your own. Okay. It really isn't. Okay. Now, what if I do something different? What if are those 3 points collinear?
Yes.
Okay. How many segments are there? 2?
1.
3, aren't there? There's 2 small ones and the big one, isn't it?
Yeah.
Now, if they're all collinear because they're on the same line, remember that term?
Uh-huh.
So let me ask this: if I walk from here to here and it's 3 feet, and I walk from here to here, it's 2 feet. How much did I go? What did you do? That's all this is, guys. That's all this is. This is called segment addition. This is nothing that you've never done before. Segment addition. Whenever you have collinear points, you can add the distances between them. 2 small chunks make the large. 3 small chunks make the large. 4 small chunks, it doesn't matter. In this case here, my 2 small segments, if I have 3 points, AB, BC, what's the whole thing? There all it is. Notice what's repeated in the middle. B. The B point. It's not the middle of the segment. That's something else we'll talk about tomorrow. But somewhere in between, B is in between A and C. Now, the long-winded definition for this is awful. If three or more points exist on a collinear, the sum of the whatever, something stupid. 2 small chunks equal the large. Small chunks added together equal larger chunk. Makes sense. You've done it before. Just like I said, 3 feet plus 2 feet is?
5.
That's all it is. Okay. Now, what this allows you then to be able to do is, let's say this was 7, and the whole thing here was 31. What's the missing piece? How much?
3.
It's okay. It's like day 2 of actual math. I'll give you a little slack. Tomorrow. Bless you.
See?
I thought you sneezed.
No.
Oh.
Ah.
Well, then screw you. I'm just trying to be nice. You could have just said thank you.
Thank you.
You're welcome. Yes, sir.
24.
Thank you. Watch what happens here. You have this geometric terminology, this whole crazy looking thing of what's called segment addition. It's written out in long-winded terms by breaking it into smaller pieces, but in essence, 7 plus what is 31? 24. It's a one-step equation. This is what happens with this stuff. That's all that is. Okay? It is not crazy, difficult, scary math. That's next Tuesday's math. High school. Remember I told you 80%, 20%? Did I tell you that? 80% of the stuff I tell you is true, the other 20% is just all BS. That was a 20. Yes, sir. Yes, sir. What's that?
I didn't write anything down.
It depends. If you can figure this out, you'll be fine. Try another one. Numerical valued ones. These are super fast, super easy to work with. I will suggest one thing. As we get into this a little bit further, we're not going to see as many pictures. You're going to have just terms, where you would have to create your own picture. One of the suggestions that I would make is to take 3-4 seconds extra on a problem and write down exactly what you have. What are the two smaller segments here? What do they have to add up to equal?
FH.
FH. But I'm not saying you're wrong. You're right with 36, but see how you told me the two lettered ones first?
Yeah.
Write that down. We know that FG
Okay.
and GH has to equal FH. The reason why I would say to write it out long form for a quick second is because in about 2 or 3 minutes, we're going to have algebra stuff thrown in there. We'll have X values of what to solve for. But the process is going to be the exact same. It helps you to see where things are going to go. That's why I take a minute and write things down. Okay? Now, with adding segments together, let's see, we have 21 plus something, and it had equal, what was it, 36? What's the something? 15. Okay. You guys are all like, man, home geometry's like this all the time. Did I math wrong? I wouldn't put it past it. But you're saying wait.
You gotta make sure.
Okay.
Yeah.
What did I do? How did I get rid of the 21? Subtract, okay. Are you okay with me skipping a step here or there?
Yeah.
When there's straight numerical ones like this, I tend to just kind of write down answers because I'm assuming that we don't need to show all the work. If you show your work, that's great. Oh, I'm Mr. Murphy, nice to meet you.
Hi.
What's that? It's an angle, isn't it?
Yes.
Okay. Now, how many angles are there now? 3. So if segment addition talks about 2 smaller segments adding up to be the larger, what do you think that is? If segment addition is 2 smaller segments added up to larger, what's that? Angle addition. 2 smaller angles add up to equal the larger angle. Does any of these rules change?
No.
Not at all. Not at all. So quite honestly, guys, yes sir.
So is it just like in pizza or pie and cutting smaller pieces?
Pretty much. Pretty much. What happens then, what you're talking about though with the pizza, is you're talking about fractions.
Yeah.
Halvesies, quarters, you go eighths when you do it the other way through here. And then this is, I'm not really good at drawing straight lines.
I know.
And so on and so on. But yeah, that's the idea. Yes! You don't know how happy I am for that. I'm gonna go find somebody and tell her that I finally did it. Anna Freeland would do that all the time. She'd just throw it on there, jump on there. I could never get it to land.
You have us clapping as we do it.
Mm-hmm. I'm an idiot. That's okay.
Oh no, there's algebra involved. Oh no, I don't know what to do.
What do you think the first thing I'm going to do is? Write it down. I'm going to write it down. I'm going to write down what the statement means when I put stuff together. Sure. Somewhere along those lines of something, yes. Just like I was showing you guys earlier with just numerical stuff, I still like to write down the lettering that I'm given. Once I'm given lettering of information, I know that I have collinear points. I know that segmented addition has to work. Smaller segments add up to equal to larger segment. So I just write down EF plus FG has to equal EG. And now all I do is fill in the blanks. It is so much easier to do something like that, especially as things become more complicated. You know, eventually we'll have formulas with weird stuff thrown into them, and if you can write down what it means in basic terms, it's nothing more than filling in the blanks. And it's something that looks awful becomes a lot less awful, or awful-less, whatever. So fill in the blanks. EF is 8x minus 14, 4x plus 1, and it has to equal 59. Exactly. You combine like terms then. What's 8x and 4x? 12x. Good. If you're wearing sandals, you're able to figure that out really easy. You're wearing sandals? Because you can count on your toes then? All right. Pace yourself. Negative 14 plus 1. To start out the school year, this is about as complicated as the algebra gets. Two-step equations. You might have to add and subtract, add, multiply, add, divide, or subtract, whatever. We don't really deal a lot with square roots or squaring or anything like that. There may or may not be a time you have to distribute something, but for the most part, this is about as complicated as we go. Yes, sir?
My brother's in algebra too, and he told me negative 2 minus 1 is negative 1.
-2 minus 1 is -1. He's wrong.
I said that. It was,
-2 minus -1 is -1. Maybe he just forgot a double negative. It became positive. It's like 3 lefts make a right.
and then he made me go get a calculator and check.
What do you do first? Add 13. Obviously, right? So then now what do you do? Ooh. Divide by 12, and your answer is?
6.
Very good. Now, here's the deal. In algebra, you basically stop. You'd solve, because a lot of times the problem said, hey, solve for x, solve for x, solve for x. The difference between algebra and geometry is that, yeah, you're still doing the same math, but what happens then is they might ask you to figure out a value of a segment, a value of an angle, a side length here or there. I think this one asked us to figure out what were both EF and FG, so what would you do with the 6?
Plug in.
Are you doing electrical work? No, you substitute. Oh, sorry, it's a bad joke. So you take the 8 times 6 minus 14, 4 times 6 plus 1, you get 25 and 34. And those would be your answers. What's that? And hopefully they equal 59. If they don't equal 59, you know you done goofed. Okay? You know you done goofed and you gotta go back and fix it. But yeah, this is the complexity of the things that we start out with here, guys. And I don't think it's gonna be too difficult. Yes, sir? Yep. What's that? Yeah, that's all we're doing today. That's all we're doing. Take a couple minutes as you write all this stuff out. We have 3x plus x plus 8 is the 32. What is that, 24?
Yes.
Yeah, x equals 6. Now, it asks you to figure out what VW was, so all you have to do then is take the value of x. 6 plus 8 is? There you go. Very good. Do the same thing on the next one.
Oh, yeah, I messed up.
We have xy plus yz is 27. Combine like terms again? Yes, sir. Oh, what do I do? And you get? And you could probably figure out the answer from looking at that, I hope. Where does I? See? I was trying to kick you out, but you weren't listening. You didn't get my sarcasm.
I thought you were just like the door.
Yeah, get out of here. So if x is 5, y is z then is going to be 3 times 5 is? Subtract 4 and you get, or excuse me, subtract 1 and you get?
14.
All right.
Wait.
Okay. Hopefully. You'll be all right.
No, because I got like 26 teacher algebra homework now. I have like weekly. Math is not working out.
Let me just show you this real quick. Sometimes you are going to be given a larger diagram. Sometimes you're going to be given a larger diagram, and they're going to ask you multiple questions off of one diagram. And this happens a lot in geometry.
Okay.
My suggestion when this occurs is to avoid at all costs the questions. The reason why I say that is because if you start looking at the questions and answering them in order, you're probably going to just take too long to do that. So what I did here was I just kind of blocked away the questions. See those two tick marks I put in between the PQ and the QR?
Yeah.
The reason that I did that is because they said that they were equal. The two segments are equal in length. When segments are equal in length, we call them congruent. To show that things are congruent, things that are equal, they get tick marks. And you get a little slash mark or whatnot. You'll see one tick mark for two between them. You might see 3, whatever. But that's what that stuff stands for. So if two segments are the same length, and they both add up, and they add up to 18, what are they both? 9. Very good. Pretty easy, straight math there. Nothing crazy. These are both 9s. Now, if this chunk from here to here is 18, and the whole thing is 46, what do you do to figure out RS? You subtract. Very good. So if I subtract take 46, subtract 18, what do you get? 28. Good. So now what happens then is that just by taking a minute to fill in everything you possibly can figure out from the diagram of the very minimal amount of information you had, you can go back and answer questions. Yes, ma'am?
Does it have to be diagonal?
No. They're just collinear. It's just a picture. It doesn't. They don't have to be diagonal like that. It just means they're collinear. All right. I just wanted to show you that real quick. I didn't want to get too crazy with it. The congruent, this. Oh yeah. We're going to stop there at the midpoints because we don't need to get into that today. We'll do that tomorrow. So this is not what I want. I just want 9 through 19 odds. Then if you give me a second, I'll put it up on the board so you can just probably take a picture of it and just go through it. Okay? Real small amount today. We'll worry about midpoints and how all that stuff works tomorrow. And we'll continue working off of that. What do you think a midpoint is?
The middle.
The middle. Yeah, the point in the middle. Pretty obvious there, right? It's basically anything that cuts a segment in half. All right?
Yeah.
You want us to turn in the homework?
No, sir. We will go through all that fun stuff when we are